Assalamualaikum warahmatullahi wabarakatuh. Introduction for classification of the fluid. First, we have to know what is the meaning of fluid. Fluid is a substance in the liquid or gas phases. The figure below show the solid, liquid and gas phases. Fluid mechanics. Fluid mechanics is a two type of fluid, which is fluid static and fluid dynamics. Fluid dynamics mean by considering the fluid mechanics at rest, which is zero velocity. Now I want to talk about properties of the fluid. First property, any characteristic of a system. Intensive, those that are independent of the mass of a system, such as temperature, pressure and density. Extensive is those whose values depend on size or extent of the system. Lastly, specific properties is the extensive properties per unit mass. The figure on the right show the difference between extensive properties and intensive properties. Continuum. Continuum is the method of a widely spaced in gas phases field of atoms, which is continuous, and homogeneous method which no hole. This continuum can only be happen when larger enough room for the distance of each other molecules. It means that the continuum is valid as long as the size of the system we deal which is large relative to the space between the molecule. The figure below show the continuum can be happen despite the relative large gap between molecule. A substance can be treated as a continuum because of the very large number of molecules, even in an extremely small volume.
Density and fluid flow. Basically, we know density is mass per unit volume, kilogram per meter cube. As for the relationship for this property with fluid flow, we can see at the steady and unsteady fluid flow. For steady flow, density remains constant. It means that density change over time is equal to 0. And for the unsteady flow, the density will change over time. It will not be equal to 0. But in the fluid flow, we can see that most of a fluid flow start with the unsteady flow at the beginning, but then it will slowly become a steady flow. So it means here the density of the fluid flow will change at the beginning, but it will remain constant, which is the same later on. Compressible and incompressible fluid. Compressible fluid defined as the flow in which the density is not constant, which means the density of the fluid changes from point to point. The change of density over time is not zero, so it will change. Density is the property of fluid. If the fluid is compressible, it can change its density, which depend on pressure and temperature. So let's take an example. If we can compress the fluid, that means we apply a pressure on the fluid. So technically, the density of the fluid will increase. But as we release the pressure, the density will decrease. For the incompressible fluid defined as the flow in which the density constant, which means the density of the fluid does not change from point to point. So the density change over time is equal to 0. This means it will remain constant. Since it is incompressible, so there is no pressure. So the density cannot be changed. Viscosity. Basically, density of fluid affects its viscosity. Fluid with more mass per unit volume are heavier, so it requires more energy to move them and shear less easily. A temperature rise decreases the viscosity and density. If the temperature decreases, the viscosity and the density of fluid will increase. So it will become more or less slippery. So the fluid will become harder to get shearing between layers.
Okay, next, for vapor pressure and cavitation. The saturation of vapor pressure is the pressure of which fluid passes from the gaseous state to the fluid state at the given temperature. Cavitation is the formation of vapor bubble due to a pressure drop. In forming a bubble, increase the volume of fluid present in the low pressure zone. Classification for vapor pressure is compressible versus incompressible flow. Incompressible flow is the density of flowing fluid remains in a constant through a liquid flow. Compressible flow is a density of fluid change during a flow or high-speed gas flow. Classification for cavitation is viscous flow and inviscid region of flow. In viscous flow is a flow in which a frictional effect is significant. Inviscid flow region. In many flow of practical interest, there are regions, typically regions not close to solid surface, where viscous force are negligible, small compared to inertia of pressure force. And okay, for next is energy and specific heat. Energy can exist in numerous forms such as thermal, mechanical, kinetic, electric, chemical, and nuclear, and there some constitute the total energy of a system. For specific heat, is a physical properties of matter. It can be defined as the amount of heat to be supplied to the given material to produce a unit change in its temperature. And classification for energy is natural versus forced flow. Natural flow is fluid motion is due to natural means such as buoyancy effects, which manifests itself at the rise of warmer and those lighter fluid and fall cooler and those denser fluid. And a forced flow, a fluid is forced to flow over a surface or in a pipe by external means such as pump or fans. For specific heat, classification is internal external flow. External flow, the flow of the unbound fluid over a surface such as plate, wire, or a pipe. Internal flow is flow in pipe on down of fluid completely bound by solid surface.
Next, compressibility and speed of sound. The amount of volume change is different from different fluids, and we need to define properties that relate volume change to the changes in pressure and temperature. We can divide the properties to two, which is the bulk modulus of elasticity and the coefficient of volume expansion. Coefficient of compressibility, also called bulk modulus of compressibility for fluids. The coefficient of compressibility represents the change in pressure corresponding to a friction change in volume or density of the fluid while the temperature remains constant. This is formula for coefficient of compressibility. For ideal gas, the coefficient of compressibility of ideal gas is equal to its absolute pressure. The coefficient of compressibility of gas increases with increasing pressure. After that, coefficient of volume expansion. The coefficient of volume expansion is the variation of the density of a fluid with temperature at constant pressure. Next, the formula of coefficient of volume expansion. For ideal gas, the volume expansion coefficient of ideal gas at the temperature is equal to the inverse of temperature. Next, speed of sound and Mach number. Speed of sound is the speed at which an infinitesimally small pressure wave travel through a medium. This is formula for speed of sound. It used for any fluid and for any ideal gas. Next, Mach number. Mach number is the ratio of the actual speed of fluid to the speed of sound in the same fluid at the same states. The Mach number depends on the speed of sound, which depends on the state of the fluid. This is formula for Mach number, which is m equal to v over c, which is v is speed of flow and c is speed of sound. Mach number can use to explain the classification of flow, which is the compressibility versus incompressibility flow. We can use it to analyze the system that involve high speed of gas flow.
Viscosity is a measure of resistance to fluid flow as a result of intermolecular cohesion. In another word, viscosity can be seen as internal friction to fluid motion, which can then lead to energy loss. Fluids with a high viscosity, such as syrup, deforms more slowly than fluids with a low viscosity, such as water. Unit of viscosity is kilogram per meter per second or Newton second per meter square. It is related to internal versus external flow and viscous versus inviscid region of flows. There are two main formulae in this subtopic. First is Newtonian fluids. This is the Newtonian fluids formula. Mu is the viscosity, T symbol is the shear stress, and du per dy is a rate of shear deformation. Second is kinematic viscosity. This formula is quite simple, and we can see that V is the kinematic viscosity, mu is dynamic viscosity, and rho is density of the fluid. And there are the formula for gases and for liquids. The unit is meter square per second or stroke. In conclusion, the viscosity of liquids decreases and the viscosity of gases increases with temperature.
Now, I want to tell about surface tension and capillary effect. Surface tension is a contractive tendency of the surface of a fluid that allows it to resist an external force. It is an important property that markedly influences that ecosystem. In this picture, we can see molecules in the interior of a liquid is under attractive force in all directions. However, a molecule at the surface of a liquid is attacked on by a net inward cohesive force that is perpendicular to the surface. This effect is also called surface energy. It requires work to move molecules to the surface against this opposing force, and surface molecules have more energy than interior ones, higher force of attraction at surface. The formula for surface tension is the work done per unit increase in the surface area of the liquid. That is a formula for the surface tension. Capillary effect. Capillary effect is the rise or fall of a liquid in a small diameter tube inserted into the liquid. The strength of the capillary effect is quantified by the contact angle. Contact angle is the angle that the tangent to the liquid surface makes with the solid surface at the point of contact. That is the picture of the water and mercury. The water is raised in a glass tube because its contact angle is nearly 0 degree. Surface tension therefore exerts an upward force when it flattens the surface
to reduce its area. Besides that, the mercury is suppressed in a glass tube because its contact angle is greater than 90 degrees. Surface tension exerts a downward force as it flattens the mercury, suppressing it in the tube. Fluid flow for the capillary effect is viscous versus inviscid of flow. Viscous flow is flow in which the frictional effects are significant. The inviscid flow regions is in many flow of particle interest. There are regions where viscous force are negligibly small compared to inertial or pressure force. The fluid flow for the surface tension is internal versus external flow. External flow is the flow of an unbound fluid over a surface such as a plate, a wire, or a pipe. And internal flow is the flow in a pipe or duct if the fluid is completely bounded by solid surface. That's all from us about the slide. Thank you. Assalamualaikum.